Right, I presume everyone can see this.
Yep, that looks good to me. Yeah, thank you.
Okay, very good. Right, so yes, thank you very much for the introduction. Today I will be taking up your time talking about synthetic data generation for sharing and research. So this is going to be a case study for the most part. I mean that we started this journey, I think in maybe this time last year. And at this current point, we have now shared synthetic data with a research partner. And so I'd like to talk you through that, what we've learned, and how we got to the point we're at now. So first of all, why synthetic data? I'll come on to what it is a bit later, but for now, why synthetic data? So the problem that we were facing, so for research purposes, so the government in around 2023, maybe 2022, the Goldacre report, and before that as well, but there was a major push after the Goldacre report to increase the access to data for research through SDEs. And this has absolute strengths, centralizing access to healthcare data. The strengths being sort of it's real data, you can make inferential sort of decisions from that. You can publish policy-making sort of decisions and research. It's reproducible as well, and there's governance embedded in that. But thus far, those benefits haven't been seen, at least on a local front within our sort of area of Wrightington, Wigan and Leigh. And those weaknesses, for example, are long delays in access to these SDEs, if at all. Restricted tooling, you need to use the tools that are present within these SDEs. There's barriers to collaboration as well. I think a very key one that I'll touch on a lot throughout this talk is that early stage research is less efficient. So hypothesis generation sort of work, model design, that sort of thing, it's not conducive to using an SDE for that. Really, SDEs seem to be more of the fancy that you have an idea, you have a big project, and that's why you would go and access these. And so we thought there's a place really that the synthetic data, that synthetic data would sit, which would be sort of the earlier sort of research work. And in fact, our story is quite similar to this. So my background by training is I have a PhD in biochemistry and molecular biology. And when I became a data scientist as my second career, about 6 years ago now, but 4 years at this trust, I was acutely aware of the imposter syndrome I was facing. And so I would make lots of meetings and discussions with local universities and their academics and computer science departments, operational researchers, that sort of thing, to fill in gaps that I had. Thankfully now I think I have a good handle of my known unknowns, but I made a lot of contacts. But when I first started here 4 years ago, I would talk to these collaborators or potential collaborators. We'd have various chats in person or over Teams about projects that we wanted to do together. And the questions they would ask were, one, we don't know what data you have. Therefore, we don't have any questions that we know to ask. Two, we've tried to get access to data in the past, but that's gone nowhere, and there have been lots of delays. And I couldn't answer them. I didn't know where to point them, how to get these data, and I would ask internally, and people would be as clueless as I was. And that would result in missed collaboration opportunities, and beyond that as well, maybe unfairly, but I think perhaps it would be a reputational damage as well. I was naive. I would sort of say, I think we can do these things, and then nothing will be delivered. And so there were these costs, I think, to some of the conversations I was having early on. And so, as I said, about a year ago, just over a year ago, we decided to take a venture sort of into the synthetic data sort of space. We knew that synthetic data was something that obviously exists. We hadn't seen it applied within the NHS space at that time. Perhaps it had, but I had a good peruse of the literature. I couldn't see it used too much. And we thought that it might solve some of those sort of problems of giving people a taste of the data that we have without all the unnecessary delays to access. But we need to ensure that if we were going to create synthetic data, we do it properly in a defensible way, whereby we ensure that the data are as private as possible, and we prove that, we show that it is as private as possible. So this comes on to the case study that I will be using as the framework for the rest of the talk. So a project that we worked on was developing a digital twin internally. And we started this internally, and it was essentially it's sort of a simulation, but you might have some short-term horizon predictions you want to make from that. So you might want to simulate a pathway, and then you may build in some or plug in some predictions on top of that. We found that there were some challenges doing this internally, and so we discussed the potential of onboarding external expertise. So I approached one of my contacts at Lancaster University. They put me in contact with an operational researcher who we got to know and developed a personal relationship with, and then onwards we now have a professional relationship where they've been assisting us with methodology and model design toward this work. And so for their benefit, they get to see these data, they know what it looks like, they have potential for publications as well. And onward from that as well, a very important point I think is that synthetic data is just a start. It sort of it allows people to ask questions or to generate questions, and then onward, our plan is that we can then go toward applying for ethical approval to get access to the real data afterwards. That's a brief overview of what I envision the problem is currently with access to data for research and how I think synthetic data sits within that. So at WWL, we have a program for data for research. It's still quite new, and the synthetic data arm is the most far along part of that, but it looks a bit like this at the moment. Just to focus in, I think, on the OMOP CDM part. So we have a request coming in, and then we have OMOP CDM data. If you're unfamiliar with this, OMOP stands for Observational Medical Outcomes Partnership, and the CDM part is the important part. It's a common data model. What that means, I don't quite like the use of model as a sort of catch-all for many things, but in this case, models essentially means that it's a standardized form or a standardized data set that if you adhere to, you could, for example, use our CDM at WWL, and you could join it to a CDM in Brazil or something, and you could cleanly join those because the columns are the same and the data types within those columns are the same. Anyway, we have a large program of work at the moment transforming our data to fit these standards. All that to say that we create synthetic data currently from our OMOP CDM datasets, or that you could do it with anything, but at WWL, that's what we do. We then go through an assessment and approval process. It's going to be a key part of the talk going forward, is that creating synthetic data is a skill, but assessing it is where you get the ability to say, right, we can share these data. And we created a tool in collaboration with the Science and Technology Facilities Council in order to assess our data robustly, our synthetic data robustly. And then we go through an approval process and we fulfill that request. So that's an overview of our program. But I said at the beginning, I would come on to what is synthetic data, as it's often used as a synonym for different things. So there's synthetic data, there's anonymized data and pseudonymized data. I don't often like to use too many bullet points in my work, in my sort of presentations, but I think I want to get this completely clear, is that synthetic data is artificially generated data that mimics the statistical properties of real data. And this is important. It's entirely new data generated from a model of the original. Conversely, anonymized or pseudonymized, they transform real data. So to put another way, if for some reason you need to keep someone's name in a data set, an anonymized data set may transform that into a fake name, but the rest of the data may remain original. Whereas in synthetic data, you have an original data set, you create a model of that original data set capturing the relationships between columns, and then you sample from that model itself. And so the new records you have are totally original. I guess I shouldn't use the word original twice there, but they're totally different from the original. And so there are multiple ways to use synthetic data, and we use these all the time, actually. That I'm sure many of you are data analysts or scientists, or just do that sort of work in your spare time, you've used some of these methods, but I've already touched on how we can use synthetic data for generating questions, hypothesis generation. Training and education is good as well. So we share some synthetic data with Lancaster University for their master's data science course currently. And just a point of interest, the piece of work that we get for them to do is one I failed to do internally, or our team failed to do internally, not because we couldn't do it technically, but because it was very hard to predict, which is length of stay of patients. And we thought it'd be interesting to give them a piece of data that's synthetic and compare the synthetic findings to our original, and they concord, they're very similar. So it's just a piece of evidence lending support to our synthetic data production methods. Analytical use as well. So if you've done some machine learning and you have a imbalanced data set for which you're trying to predict, it's a classification model, you're trying to predict a sort of lowly proportioned class. So you have some sort of disease that's a low frequency in the population. And something you could do is you could overexpress, boost that lowly expressed class using certain methods. And when you do that, you hope to pick up certain patterns that you wouldn't have been able to pick up otherwise. And when you do that, that's a form of synthetic data creation. You are inflating the numbers of that rare event by creating new records of it. That is artificial, that's synthetic. And a very common one is imputation or data completion, where you may have a column of data and you may have some missing values that, and you think those missing values should be filled. And in the very simplest of cases, you may take the average, the median or the mean of the rest of that column to fill in that value. That's a form of synthetic data as well. But in our case, we're interested in this data sharing provision, privacy preserving analyses that people can do, and for collaboration as well. How do we create it next? So there are various ways of creating it. I think it's beyond the scope to go into these in detail, so we won't. But to give you a flavor of the different methods that are available, machine learning models are available, statistical models. Gaussian copula is the most common. I wasn't familiar with this until I started using work in it, but it seems like it's it's sort of the logistic regression of models for synthetic data users, sort of a workhorse of the field. My experience shows me, though, that actually it's not sufficient to use one of these models. Hybrid approaches are the way to go. And a hybrid model is simpler than it sounds, perhaps. So you do the modeling, you choose a model, and then beyond that, you use certain logic rules to apply to the model as well. So what this essentially means is there might be, so models, synthetic data is very good at capturing relationships between your variables, but some relationships are exact. So for example, let's talk about something like News2, so National Early Warning Score. The way that is calculated is a sort of a summation of physiological variables. And you may have columns that are each of those physiological variables, and you may have a final column that's a News2 score. That News2 score must always equal the sum of those physiological variables. Synthetic data generation isn't good at that. So if you need something exact, then you need to do some work post hoc and pre data engineering to ensure that. Another example is dates as well. So if you have sequential dates, so referral dates all the way up until discharge date and dates in between, they need to be sequential. You can't have one earlier than a previous date. So those are things that aren't captured very well, and so you need to do some sort of hybrid approach is required here. I have touched a bit more into detail into how a Gaussian model is made. Gaussian copula model is created, but in short, once again, real data, you fit a model to that, you sample from the model, you have now a synthetic data set, and you evaluate that going forward. In a bit more detail, I think it's just important to say here, without going into it too much, I think the first point, transforming data, first point I make there is that you de-risk the data as much as possible. So when you're creating synthetic data, two things need to be borne in mind. One is that you minimize the data as much as possible. If there's anything in there that isn't required, so a person's name or a person's NHS number, you just strip them out straight away. They're not required. Further to that, you can transform certain variables. So a person's address, you may not need all of their address, but you could keep the first three numeric characters of those postcodes, and that could give you some information that's still useful. And yet it doesn't allow for the full possibility of it being leaking sort of information there. Another one is that you have ages and they're a continuous numeric variable. Instead, you could group those into buckets of 5 years. There are various things you can do to de-risk the data as much as possible before you apply a model to it. I think I've captured this already, but essentially within this model, the Gaussian copula model, you transform data into a standard normal distribution. You then capture those patterns between, or the patterns between the variables, the columns, and a multivariate normal distribution is fit to capture that. You then generate samples from that, and you transform the data back into a scale that looks like the original data. It's fairly straightforward, and to be honest, it's not the hardest part of creating synthetic data. The hardest part is the iterative process that I'll come on to later, the creation, and then the assessment, and then going back to the creation, and then making it better. We'll talk about that next, I think. And that's really critical. Is the synthetic data any good? Because right now we've created synthetic data. I've talked a bit about the assessor, but being able to assess really, is it any good, is the hardest part. And so, as I mentioned earlier, we did work with the Science and Technology Facilities Council, a collaborative piece of work, to develop a tool, a Python tool, that helps us with this. Before we get onto that tool, I think it's just important to note that there are two groups of, I guess, traits that are useful to bear in mind here for assessing performance, and they are privacy and then analytic utility. So you want something to be as private as possible, but you also want it to be as analytically useful as possible. I think a definition of that could just be something like the analysis that you do on the original data set. If you do that same analysis on the synthetic, that you get similar results. However, there's a trade-off there. The more private, often the less analytic utility it has. And so it's useful to bear that in mind. You often can't get a perfect world in this work. So the synthetic data assessor, once again, built in collaboration with SCFC. And the way that this looks, I said it's a Python script tool. So on the left-hand side, starting there, we have the original data. We have twice over, so training and holdout, and a test data set. Just to linger on this for a second. So holdout data is very important. Just to say how this is made, so you have training data, and the synthetic data is made from the training data, and the holdout data is never seen by the synthetic data, so it's totally separate. And why this is important is because it gives us a measure of something. So if without the holdout, you can't tell if privacy is good in your set because it generalizes to other data, or is it overfitting? Has it memorized something about the training set? So in a optimal scenario, when we look at our performance metrics, we'd expect similar performance between the training and holdout. If there's a vast disparity there, it usually means that something is leaking from the training into the synthetic to mean that it performs very well on this data, but not on these data, but not on this one. So anyway, you feed these three data sets into the assessor tool. You also define sensitive variables that exist within that. So maybe a diagnosis. If you have three numeric character, the prefix of the postcode left in, then you will also perhaps put that as that would be a sensitive variable as well. Age, even if you've de-risked it as much as possible, would still be a sensitive variable. So you need an understanding of what sensitive means, basically. That diagnosis would also be one of those as well. So you define this all, you feed in those data sets, and the script spits out 11 privacy and utility metrics, which I'll come on to now. So I will hover over these slightly but maybe one or two of them. But really, we chose these metrics because they do two things, or a few things actually. One is that we wanted our reasoning for accepting synthetic data to be shared, to be explainable. So we wanted to have a good coverage of different privacy metrics. So the reason we have so many is not because they all do the same thing. These privacy metrics often do slightly different things. So for example, k-anonymity and L-diversity, they work synergistically. I'll come actually onto that into the next slide, I think make more sense with numbers. But there are things like hitting rate as well. That tells us if there's anything that is directly copied from the original to the synthetic data set. But they all sort of capture a different essence, let's say, of privacy. And similarly with utility as well, they capture differences there with utility. And we chose these similarly as well because although within the NHS synthetic data is more of a nascent sort of area, in other areas there is regulation around how to create synthetic data, and so we chose these to overlap with data protection regulations that have been enforced elsewhere. Okay, and so this is just an output of what our tool creates. I will send these slides we sent around to anyone who wants to look so you can see this in more detail. But just to maybe hover over two of these, so k-anonymity here, 96, and L-diversity here at the top right actually is 1. K-anonymity is quite interesting. It's basically, it says how many, what is the lowest number of records that are indistinguishable from each other. Maybe that's quite complicated, but it says that essentially 96 of these, of the rows, the records, are the exact same as each other. That's very good, actually, from a privacy perspective, because the lower the number, the more it's like, well, actually, maybe we can infer who that one person is that has a very distinctive row all to themselves. Whereas if it's 96 people all having the same thing, then that's harder to infer who an individual is from the 96 that have the same thing. But L-diversity tells us, extends that a little bit, and it sort of says, of the sensitive columns in these 96 patients, how many different, let's say, diseases, in this case, cancer diagnoses, are there? And in this case, it's saying 1, and that's very bad because it's saying, yes, 96 people all have the same record, exactly the same record. However, they all have this exact same cancer diagnosis. So if you try to infer something about a person, and that thing you're trying to infer was the disease they have, you would know it despite the fact they have a high k-anonymity. Their L-diversity score being very low means that someone could infer what disease that person has if they're trying to. And so you have to, what I'm trying to say basically is that you have to look at these metrics holistically and not on their own. Once again, this will be shared so everyone can look at this on their own, but just to give you a flavor again, this is utility metrics here as well. And so we have some very simple things here like confidence interval overlap. So do the means essentially overlap each other? So if they don't, then what's very useful about this work, and I'll come on to this in a second, is that the output we get from the tool, if we were to drop down this menu here, it tells us which columns don't overlap. And so there are differences here between the synthetic and the original that perhaps we could improve by going back to the original data set and maybe transforming the data differently or doing something to it, maybe tweaking the parameters of the model. There are things that we can improve, and that's an extremely useful aspect of this tool. Similarly, here is another interesting metric that we get. So propensity mean squared error, essentially it runs a logistic regression model between the original and synthetic data. And what this does is, if it was a very, very good synthetic data set, very similar utility to the original, then you'd expect that you wouldn't be able to predict a difference in which columns are, which data are the original, which are the synthetic, and the lower the score, the better. But in this case, it's telling us that actually we can see that there are certain variables here that are predictive of the data set being from the synthetic versus the original. We don't want that, and therefore what we would do is we'd use this information to go back to our original data set and say, right, these columns here need improvements. Let's try and transform them and see how we do. Similarly, again, with this KS score as well, looking at a measure of the distribution differences between the two data sets, we could go back and say, right, these columns need some improvement. Is it worth doing is another question as well, because there is a part of the work, which I'll come on to in a second, which is when you are sharing synthetic data, you need to bear in mind, or when you're creating synthetic data, you need to bear in mind why the person needs it. if it is simply for model development, then maybe some variables don't need to be as similar to the original. Whereas if you need to have high fidelity between an original column and a synthetic column, then it would be bad if that came up here as significantly different, and you would need to do some data engineering to improve it. So as I've mentioned, it's an iterative process. You make synthetic data, we then use this tool we built collaboratively with the STFC. We get the output that we saw in the last two slides, and then we look at those, for example, privacy metrics. If we're happy with the privacy metrics and that the data are very private, then that's great. We can then look at the utility metrics. But if the privacy isn't good in the first instance, we'd improve that first before we care about the analytic utility. Once you get to the analytic utility portion, it is a long process, I'd say at the moment. It's an art form really of trying to go back to the original data and re-engineering it, transforming data to improve the performance metrics and back and forward. But sometimes, as I said, the use case really does determine how much analytic utility you need. And if it's just for model development, then perhaps it doesn't matter so much. If it's a hypothesis around a certain condition, then perhaps you want higher fidelity there in certain columns. And yeah, this really comes to the point of when is synthetic data good enough for sharing, as I've tried to describe. So there are no single metric is good enough for determining suitability alone. And to do this, we would base our decision on multiple signals. And I've just mentioned this, the context as well. I've captured this, I think, in my statements earlier, but they capture different risks. And I use this example of high k-anonymity, low L diversity. In terms of use cases, for this work, for example, if you're developing a method, then some utility loss could be acceptable, so you accept lower scores. But yeah, if you want to maintain fidelity, then you may need to make sure those columns don't crop up as being significantly different. And then logical validity, I touched on this as well about the sequential nature of dates. So temporal consistency, you want to make sure that is still the same and still correct. And what that usually looks like is something like, or what I've learned is that you might, for example, keep the first date, and so the referral date column. And then if you have an attendance column, instead of that being another date column, what you might have is in the original data set, you might transform that into a days since referral column. And then in the post sort of hoc work, after you have the synthetic data, if you needed to, you could transform that days since column into a date by adding that to the referral date column. So that's a way that I've got around some of these problems. And then finally as well, data minimization, only including what is necessary into the model. I think just to give an overview then, so the internal approval process that we sort of follow at the moment is, yeah, we have synthetic data, we create that, it's assessed by the tool. What we have then done is we created a sort of a data access group internally, where myself and the information governance lead. So just to notice as well, all of this work was done with them as a key stakeholder in terms of the production of this tool and the synthetic data work. The information governance lead was in that throughout. We prepare a summary together. We then bring that to the data access group, and in that summary, we recommend whether the data should be shared. Present it to the data access group, and this is a key point as well, is that this work is clearly quite technical. There's lots of performance metrics there that actually require understanding before you can make an informed decision about whether data should be shared. And I don't expect any of you to have picked up how you would do that from this talk, because what I've been doing is giving sort of dedicated training sessions on how to interpret these metrics and how to assess good enough, I'd say. And it's not straightforward. And so we've actually been working with STFC going forward as well to help with those training sessions. I think that's probably one of the biggest limitations of this work is the fact that to have confidence in sharing this, you need a lot of people in the right positions that understand the data and also understand the approval process, the performance metrics. And so I've talked about some of this already inherent to the rest of the discussion, but I thought I'd just touch on some of the learning that we've had. So we only had one example of sharing data. We have two, to be honest. We had this Lancaster University project, but also did sharing data with students at their master's degree course. But there is some lessons learned. So hybrid models are the way forward. I mean, they are, without them, there'll be certain things that will crop up later that will embarrass you. So for example, I said in point 2 here, data minimization that ensures privacy and prevents embarrassment. The reason I say this is because when I shared my original data set with Lancaster University, there were 2 problems. One was I didn't maintain temporal relationships between columns. I didn't come up with the idea of having a date since column to represent the next date and the next date. So I had dates that should never have been earlier being earlier. So that was embarrassing. And then the second thing was that oftentimes in these NHS data sets, you'll find that there's replicated information quite often. So an example could be that you have a did not attend column, which is both a logical 1 or a 0 value is given, but also in a second column might be a DNA column, but as a character. So it might say DNA or might say attended. These models are very good at picking up relationships, but if you need columns to be exactly the same, if you have DNA 1, then DNA in the next character column, you can't guarantee that. And so these things need to be understood when you're creating synthetic data. I mentioned the third one, performance metric, internal training is required. Yeah, this was learned the hard way because we couldn't initially share data until our group had a good grasp on what it is that they were looking at, and that's clear. And so this has been it is an ongoing process as well. And the early partnership with our key stakeholder, the Internal Information Governance League, was critical. Without them, we wouldn't have been able to defend the project we were doing. And because they were involved from the off, they were involved in the understanding the performance metrics, understanding that we were doing our due diligence in carrying out this project. And finally, I think that just to talk about the future of this program. So I mentioned many different models. I have 2 students from Lancaster University that are joining us for a summer studentship this summer, and they're going to be trialing different synthetic data models and exploring whether there's different use cases for each model and how they perform. As currently, we've only used a couple of different models, but yeah, their projects are going to be to explore the wealth that exists. Sharing data for teaching, we've already done this. We had some conversations with the University of Greater Manchester as well in Edge Hill regarding sharing data for teaching. Once again, further training internally and externally. So we are also happy to discuss in further detail this work, share the model, and talk about any aspects of what I've talked about today with yourselves. So if you'd like to apply this, please do get in contact. A very important point, I think, is this data catalog aspect as well. Oftentimes when we talk to academics, they don't have questions formed, they don't know what data exists. And so we've started a project where we are collecting metadata essentially, or relevant metadata of our tables that we think would be appropriate to serve to academics so they can have a look at what it is we have. And then if they're interested, we can create synthetic data from those. And finally, using this sort of talk and others to advertise our capability wider, and linking back to point 3 there to share it as well. Okay, well, that's a whistle-stop tour. Thank you very much for bearing with me. Are there any questions?
Uh,